Yes, hello class. Is this audible to you all?
Yes, ma'am. Good evening.
Good evening. Rayan, see, we had a class of current electricity before. One class we already have, so you will get the backup of that class. So you will be able to understand from that. Okay, Rayan, this is your first class, no?
Yeah, it is.
Okay. You will get a backup of this first class. Only first lecture has been missed. Now see, in current electricity, the first topic that we started, it was electric current, the basic concept. Now, rate of flow of charges is known as electric current, and which is charge per unit time. So when you have average current, means you have a time interval, then you use this equation, I is equal to delta Q by delta T. If you have to find out current for a particular time, like T is equal to 2 seconds, T is equal to 3 seconds, then you use this, I is equal to dq over dt. And remember, current, electric current, this is the only scalar quantity which has a direction. Then we had discussed drift velocity. So drift velocity is actually the velocity, average thermal velocity of all the electrons, because of which electrons are drifting towards the positive terminal. Electrons are drifting towards the positive terminal under the application of electric field. So this is drift velocity. And we had derived a formula for it, which is minus E capital E tau by M. E is the electronic charge, capital E is the electric field, tau is the relaxation time, M is the mass of electron. Relaxation time means time interval between two successive collision, when there's a rest period, when electrons are not colliding. See, electrons have the tendency to collide with themselves also, with the positive ion also, with the walls of conductor also. So when that time interval occurs, no, where the electrons are not colliding, then we call it as a relaxation time. So this tau is basically time. Then this relation is very important. This will be utilized in today's class as well. I is equal to NEAVD. Revise it along with me right now only, because then I'll ask you all these things. I is equal to NEAVD. This is a relation between current, which is I, and drift velocity, which is VD. A is the area of the cross section of the conductor, E is the electronic charge, and N is the number density. Number density means number of electrons per unit volume. That is number density. Then we had, okay, these two relations are important in this equation. I is equal to NEAVD. Current is seeming to be proportional directly to the area of cross section, but current is independent of area of cross section, whereas drift velocity is inversely proportional to area of cross section. Then we had stopped here till Ohm's law we had completed. Ohm's law says what? If two quantities, temperature and pressure, remain constant, then the whole current which is flowing in the conductor, this is directly proportional to the potential difference applied across its ends. Means V is equal to IR. V is the potential difference, I is the current. This is your Ohm's law. Now, whenever this current is flowing, no, what will happen? Current is flowing. Why? Because charges are moving. Which kind of charges? What type of charges are moving? Charges that are moving, these are basically what? These are electrons. Electrons are mobile charges that are moving. So when electrons move, positive ions are there, many positive charges must be there, some other entities must be there. So they would oppose with the motion of electron, with the movement of electron. So that opposition to the motion of the flow of charges which occurs, that we call as the resistance. So in today's class, we'll be dealing with resistance and a similar phenomena with resistance associated with resistance, that is resistivity. So resistance, if I talk to you about resistance, from Ohm's law, you already know one formula of resistance. Resistance is what? If V is equal to IR, then this R will be V divided by I. So resistance is definitely V divided by I. So resistance is what? Resistance is basically the opposition to the flow of charges in electric circuit. I'll write down the definition as well. Resistance, the way you have frictional forces do what? They oppose the motion. When you were in 11th, you must have studied viscosity also opposes the motion in fluids. Similarly, you have resistance for the motion of charges. So when the motion of charges gets opposed, that term, that phenomena, that quantity is known as resistance. It's a physical quantity which is given by the ratio of voltage and the current. So resistance, it is the opposition to flow of charges in electrical circuit. All right. Now the derivation for it. This formula is not enough. R is equal to V divided by I. This is not enough. You have to calculate in terms of number density. You have to calculate in terms of length, in terms of area, on all the quantities on which resistance depend. So for this, we'll take a wire. Let's say this is a wire. The length of this wire, or let's say it's a conductor, is L. A is the cross-sectional area, and it has been connected to a potential difference, a battery with potential difference V. So current I, it is flowing through it. This is what we have taken. So yes, Krishna, you tell us, what is the relation between current and drift velocity?
I is equal to NEA VD.
I is equal to NEA VD. I is equal to NEA VD. We know this. All right. Who's next? Yes, Akifa, tell us the formula of drift velocity.
Vd is equal to minus E capital E tau by M.
Tau by M. Perfect. So Vd is what? Vd is equal to minus E capital E tau divided by M. Do not get confused. M is not the mass of conductor. Don't take the mass of wire or don't take the mass of conductor, even if it is given. M is the mass of electron, which you already remember, whose value is definite. So don't get confused with the mass of conductor given to you, if it is given to you. Now let us take the magnitude. Minus sign is just telling us the drift that is occurring. So can I put the value of Vd in this? Value of Vd in the equation, I is equal to NEA Vd. In this equation, if I put the value of Vd, I'll get what? I is equal to NEA, and instead of Vd, I'm putting what? E capital E tau divided by M. This whole thing. Now, as you see, E is getting multiplied 2 times. So I can write it as NE square A capital E tau by M. This I can write. Now, Atif, you tell us, what is the relation between electric field and potential difference? Try to recall it from chapter 2. Any relation between electric field and voltage, Atif? Fatima Munir? Relation between electric field and voltage. We had also seen there was a negative sign and it had a significance. Now, if you are able to remember, we did why there was a negative sign.
It is minus dV by dr.
Minus dV by dr, correct. It is minus dV by dr only. See, then we did why we have a negative sign minus, because that minus sign shows that electric field is directed where potential decreases. So that relation, do not forget all the formula. That's why I ask you all to keep on making a separate notebook for the formulas and derivation. So E is what? E is basically, let's not consider the negative sign here as well. The way we have eliminated it in case of Vd, let's eliminate it in case of electric field, because we only want to know the magnitude. So if V is the potential difference, L is the length of conductor, electric field will be V by L. So let me put the value of E from here. It will be NE square A tau by M. And instead of writing electric field, I'll be writing V divided by L. See, this derivation of resistance and resistivity, this is not a tough one. It's an easy derivation. It's better than the derivation of drift velocity. Drift velocity's derivation was longer. Now see, if I write you what is Ohm's law, Ohm's law was V is equal to IR. Means if V is proportional to I, whatever term remains, that will be the resistance because it's the constant. So now what I'm having, this, if I write V divided by R is equal to I, it's correct also. I can shift this R in the left hand side towards the denominator. Now if you see, apart from these, V and I, whatever will be left will be 1 by R. See, I is equal to what? 1 by R multiplied by V. Both of these are equal. I can write it in this manner also. So whatever is left apart from this I, see it's matching I, V, V. So whatever is left, this becomes 1 by R. So what is 1 by R? 1 by R is NE square A tau divided by ML. So I have the value of resistance now from here. Resistance, if I take the reciprocal of both the LHS and RHS, resistance will be ML divided by NE square A tau. This is the actual formula of resistance. Mostly this formula is used in your chemistry. In physics, you have that formula. V is equal to IR, that is used, but sometimes this formula also gets used. ML divided by NE square A tau. Now, what are all these things? What is M? M is the mass of electron. L is the length of conductor. N is the number density, means number of electrons that are is situated in 1 meter cube volume. E is the electronic charge, which is 1.6 into 10 to the power minus 19. A is the area of the cross section of the wire or the conductor. Tau is the relaxation time. Relaxation time means time interval between two successive collisions. All these make up the formula of resistance. Now from here, few important points regarding resistance you have to remember, which can be seen through the formula only. Resistance depends on 4 factors, and all these 4 factors you should remember, because 2 of them will be utilized in derivation of other only. So resistance depends on what? Firstly, R is directly proportional to length. So it directly depends on length. Secondly, resistance is inversely proportional to area of cross section. R is inversely proportional to A. This A is what? This is area of cross section. Resistance depends on nature of material. Nature or depending on nature of material means if you have different materials, they'll be having different resistance. For example, resistance of brass would be something else, resistance of zinc would be something else, resistance of glass would be something else. So different material would be having different resistance. So it depends on the nature of material, as well as it depends on temperature. So temperature, you have a full-fledged topic, how resistance varies with temperature. Basically, temperature influences your number density, this N and tau. So that's why it changes your resistance. All right. Is this clear? Resistance is clear to all of you? Yes or
Yes,
no?
ma'am.
All right. So just note down this derivation of resistance, then we'll move on to resistivity. You people are not submitting your assignments. What happened? Atif had submitted that capacitor one. Kulsum has also submitted. Only 1 or 2 people have submitted earlier assignment. Last assignment, which was based on the topic Ohm's law and drift velocity, nobody has submitted. Why you people are not submitting your assignment? Hardly 5 questions were there in that assignment, and 2 questions were direct theory based. You didn't even have to calculate. That's why I gave you that question, so that it saves your time and you're able to quickly solve it. the question, the numericals that were there, we did it in the class. Then also you people are not submitting your assignments. After today's class, the assignment that I'll give you only 3 questions today. Only 3 questions. But promise me that all of you will submit your assignments so that we'll be able to discuss it in the next class. Yes or no? Will you submit now?
Yes, ma'am.
Yes.
Yes, teacher.
Done?
Yes, ma'am.
Okay, now the other quantity that I was mentioning you, resistivity. See, if you have understood resistance clearly, then understanding resistivity is easier. On which factors did resistance depend? We have seen first was length. So resistance depended on length. Resistance also depends on area of cross section in this manner. Now, if I combine all these proportionalities, what do I get? I see that resistance is directly proportional to length by area. This is what I get. Now, whenever we have to remove the proportionality sign, how do we do it? Put an equal to sign with a constant. Exactly, we put an equal to sign with a constant. So in this case, R with an equal to sign, and the constant that you get is rho L by A. Now this constant that you are getting, this is known as resistivity. So how can I define resistivity? See, in this formula only, in the formula in front of you, if I write length as 1 meter, means unit length, and area of cross section also, if I write it as 1 meter square, in this manner, 1 meter square area and length. So what will be the relation between resistance and resistivity? Yes,
Distance will be equal to rho.
resistance will be equal to resistivity. Yes. So resistivity, how can I define resistivity? Resistivity, it is defined as resistivity of a material. This can be defined as the resistance. See, if I put all these factors, then resistance will be equal to resistivity. It means resistivity is actually the resistance. So resistivity of a material can be defined as the resistance. But there are conditions valid. There are conditions that are valid. Which conditions? Length has to be unit length. So it is valid of a unit length and the area of cross section, it also has to be unit, and unit area of cross section and the unit area of cross section. So resistivity of a material, it can be defined as the resistance of a unit length and unit area of cross sectional material. You can add it. Now formula derivation is very easy. R is equal to rho L by A. So rho will be equal to what? Rho will be equal to R multiplied by A divided by length. Now R multiplied by A divided by L, I have it. But I also have the formula of R. What was the formula that we have derived? Just now you must have written it down. What is the formula? Yes, Fatima? R is equal to
ml by ne square a
tau.
multiplied
Multiplied by tau. So resistance is ml divided by n E square A multiplied by tau. This is what? Resistance. Then I will write this area and this length. So you can see area is getting cancelled, length is getting cancelled. Rho is what? This is m divided by ne square tau. Tau, if you're not able to understand, tau is the relaxation time. It's just take it as time. In your questions, time would be given. That is your relaxation time. You don't need to calculate anything for relaxation time. It's the average time interval. See, whenever electrons are colliding, one collision has occurred, two collision has occurred, then the electrons stop before colliding onto another particle. then that interval, no, we are getting, you call it as relaxation time. And average relaxation time means relaxation time of all the electrons, because we are calculating the average of it. That's why we take it. Now from here you can say, in this formula, length is not there, area is not there, whereas in case of resistance, area was also there, length was also there. That showed us that resistance dependent on the length and area. So from resistivity, can you tell how does it depend on area and length? Anyone? From this formula, what can you say? Does resistivity directly depend on length, inversely proportional to area? Which way?
Resistivity is inversely proportional to the relaxation time of.
Regarding length and area, Tif. Regarding length and area.
Resistivity does not depend on length and area.
Resistivity doesn't depend on length and area of cross section. From this formula only you can see area is not there, length is not there. So resistivity is independent of length and area of cross section. Basically cross section is like, if I have this pen with me, then this will be the cross section, this manner. If I cut it in this manner, this will be the cross section. So whenever we are referring to area of cross section, it means this only. Whole area can be this also. Curved surface area of cross section means this area. So length and area of cross section. And it does depend on the nature of material. It's not like it doesn't depend on it. It depends on the nature of material. So it depends on nature of material, and also, as Atif was rightly mentioning it, that average relaxation time means relaxation time. And relaxation time. One thing that I forgot to mention when we were discussing resistance was the SI unit of resistance. So add somewhere in your notes, SI unit of resistance, this is ohm. What should be the SI unit of resistance? Resistance is basically V by I. V by I means
Meter.
ampere. Yes, Fatma? Who said? Was it? Yes, cool.
Meter.
Ohm meter for resistance.
Resistivity.
Resistivity will be ohm meter. Yes, good question. It will be ohm meter for resistivity. For resistance, see, 1 ohm is what? 1 ohm is basically 1 volt by 1 ampere. Volt per ampere. So we have a better name for volt per ampere. That is this symbol. This symbol is called omega, and the SI unit, this is known as ohm. So we use the term ohm for it. So as she was rightly saying, the SI unit for resistivity. The way Kulsum has answered, her answer is right, because see, resistivity is what? Resistivity is basically RA divided by L. Resistance is ohm, area is meter square, length is meter, meter square, meter gets cancelled, SI unit becomes ohm meter. All right, so note down the points of resistivity. Again, revise resistance and resistivity. If you have any doubts, ask me. Then we'll begin with the questions. So the question says that length of a wire increases by 2%. You have to calculate the percentage in resistance as well as resistivity. Try to solve it. See, R will be equal to rho L by A. So try to find out the initial resistance, final resistance, take the difference and divide it by original. That gives you the percentage. And resistivity, all of you can answer without even calculation. So whoever gets the answer, submit it. It's not a lengthy question. Take 2 to 3 minutes, then we'll discuss it. Yes, Rishan, you had left in between. Were you able to understand? Did you note down all the points of resistance and resistivity? Okay, Rishan, then try this question. Are you able to understand Rayan? Yes, Rayan, are you able to understand this?
Yes, ma'am. But in between, my internet is lagging, so I can't.
Okay, okay. So which part did you miss? Okay, just look into your notes. If you're having issues, then ask me again. It's okay, you can ask.
Okay.
And what about you, Fatima Munir? Fatima, are you able to understand?
Yes, ma'am.
All right. Yes, so Kulsum has answered first, and her answer is correct. Krishna, check again. Check again. If the length increases by 2%, then there can't be so much change in the resistance, no? Resistance depends on length only. And the second part is correct. Kulsum, answer the second part also. You'll be able to do. Second part means for resistivity. Others also
Yes,
last
ma'am. I'm trying.
2 minutes, then we'll discuss. No, Krishna. Just check your calculations. I think you must have committed any error in the calculation. Just check your calculations once. All right, let's discuss it now. See, if the length of wire increases by 2%, then there's a percentage change in resistance and percentage change in resistivity, which you had to calculate. Now, if the length of wire increases, you have to understand that there will be effect on the cross-sectional area. Area of cross-sectional will also change. Second part is correct, Atif. Again, resistance answer is not correct. Just check your calculations again. Till now, only Kulsum has submitted the right answer for change in resistance. See, do not forget this factor. If I say this was the, let's say what was given, wire was given. No? So this was the wire with length L, resistivity rho, area of cross section A. Kulsum, tell me the answer for the second part. First part you have answered well. Second part? See, look.
I don't get it.
Look into the points of resistivity.
Okay, 1 second.
Hamza, you tell me, if there is a change in the length of wire, will resistivity be affected? Hamza. Few points you must have written it down. If
Resistance doesn't change.
resistance, Kulsum, resistance changes. You're talking about resistivity. Resistivity doesn't change. Yes, Fatima, you are also right. See, what we have written, in the formula of resistivity, length and area of cross section got cancelled. Means resistivity is independent. However, you increase the length by 2%, by 4%, by 100%, resistivity will not be affected. You can think it in this manner. For example, you have water with you. You have a full bucket of water. Density of water will remain 1000 kg per meter cube. If you take a single drop of water, then only then also the density of water will still be 1000 kg per meter cube. So these quantities you must have studied in your 11th. Those properties in your states of matter, you have such categories. So in that also you have two categories where one comes under resistance, other is resistivity. So that is a material dependent property. Resistivity depends on the nature of material. That is quite different. Means different materials will be having different values of resistivity. That is right. But the material that is having the value of resistivity, for example, let's say this is some nichrome wire, it is having value of resistivity as rho. Even if you take that small little piece of wire, still the resistivity will be rho only. So in this manner, resistivity does not depend on the length and area. Perfect answer, Hamza. Correct. Change in resistance is right, and resistivity, there won't be effect. Others also keep trying if you have reached a portion of your calculation. Now see, if I increase the wire, if I elongate the wire, volume is remaining the same. I'm not adding any material, neither I'm deleting any material. Material is remaining the same. So if length has been increased, what will affect the area? Area will be affected. It means if length of wire has increased, area will become narrower in order to compensate for the increment in the volume. So area will also change and length will also change. But resistivity, it will remain the same. So answer for resistivity is the same, that it is independent of material, so it will be the same. But percentage change is in resistance. For example, if I tell you, looking at this, initial resistance, it will be what? R is equal to rho L divided by. If I look at it, the final resistance R dash will be equal to what? Rho L dash divided by A dash. Now, how do you calculate the percentage change? Final minus initial means whatever is the change divided by original multiplied by 100. In mathematics, how do you calculate percentage? This is the way to calculate. So similarly, you also have to calculate here. But the problem is that we don't know what is the new length, what is the new area. Length, we can figure it out. Length increases by 2%. So new length means it is the new length. L prime will be length with the increment along with this 2% length. This is the new length. So let's find out what's the length first. What's the initial length we are getting? Not the initial, final length that we are getting. L prime will be L plus 2 by 100 L. 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 2 by 100 2 by 100 because 2%. So percentage can be written in this manner. If you take the LCM, this becomes 100L plus 2L divided by 100, which is what? This is 102L divided by 100. So this L prime becomes 1.02L. I have a relation between new length and old length. So one problem has been solved. But what about the area? So Hiba, you tell me. Right now only I told that one quantity will remain the same. Except for resistivity, what else quantity will remain the same? Hiba. Resistivity will be the same. Anything else that will remain the same? Area will change, length will change. Hanifa, any idea? Hanifa, you're not audible to us. I think you can type it. I'll read it out. Your voice is not coming. I think your mic is not working. Just check it once again. Yes, anyone who remembers it. Apart from resistivity, which quantity will remain the same in both the wires? Final and initial. Fatima, any idea?
Ma'am, area of cross section, right?
Area of cross section is changing, Krishna. If length is increasing, area will become narrower. But to maintain what? Why is the area becoming narrower? Which quantity is remaining constant?
V.
Yes, Fatima?
V. Potential.
Not potential. Akifa, yes. Akifa, unmute yourself and answer this. Yes, Kulsum. Good. Akifa, you tell us.
Volume.
Volume. See, why is the area becoming narrower? Because the volume of the material will be the same. Since there is no additional volume change there, that's why we are having this volume only. That's why area is becoming narrower and length is increasing in order to compensate for the volume. So from here you can say area will change. Area will change, but volume will remain constant. So initial volume will be equal to the final volume. Means AL, this will be equal to A prime, L prime. Now you know what is the relation between L prime and L. So put it. Just give me 2 minutes. Till the time, note it down and try to find the answer. So we were discussing that volume remains constant. So AL is equal to A prime, we don't know, but L prime we know. L prime is 1.02 times the new length. So length gets cancelled, and we now have the relation between the final area and the old area, initial area, 1.02. This is your area. Now put it in the formula of the resistance that you get. R prime is equal to what? This is equal to rho L prime. L prime is what? 1.02 times L divided by A prime. A prime is what? A divided by 1.02. So this 1.02 will go up. This becomes rho L by A 1.02 whole square. What is rho L by A? Are you able to remember it? What was rho L by A?
Resistance.
Initial resistance.
Initial resistance. It's the initial resistance. It means R prime is what? R prime, it is 1.2 whole square times the initial resistance. This was what was missing in our answer, because without this relation we will not be able to find out the difference between the resistance or the percentage change. So 1.02, this will be 1.404 times the resistance. You have R prime. Now percentage change in resistance. How will I calculate the percentage change? Final resistance minus initial resistance divided by the initial resistance multiplied by 100. That is how we calculate the percentage change. R prime is 1.0404 R minus R divided by R. Just check it once. Is it exactly like this? Because I have done it orally. So just check the decimal places. Multiplied by 100. So 1.0401 minus 1, basically that gives, this is 0.0404 R divided by R into 100. RR gets cancelled, 20 places, it means 4.04% change in the resistance. Now for all those who are getting different answers, there's a trick that you will be able to not get the exact answer, but you will be able to analyze whether your answer you are getting is correct or not. See, if the percentage change in length is X%, no, then percentage change in resistance, this is approximately 2 times X%. When is this valid? If you get your change in length as less than 5%. For example, in this case, it was 2%. So if you double it, what is the percentage in resistance you are getting? 4%. So you will be able to analyze that the change in resistance is 4%, and exact value you can calculate by your calculations. Clear? In this manner. So once you can get an idea, if your percentage change is less than this 5%, if it's more than 5%, then no need. Do the whole complete method. Clear, or any doubt?
Clear, ma'am.
So till where have you all written from here?
Teacher, I have to leave because I have to go. And I told the faculty, they said that they'll send me the recording. Is that okay if I leave?
Oh, you have your exam. What were you saying, Fatma?
No. I don't have exam. I have to go out.
Okay, 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 Fatma.
Bye. Thank you.
Okay, okay. See, in this question, you have to calculate the resistance. L is the length of the conductor, small r is the radius of the cylinder, whatever wire you are given. Josefa, you tell me what will be the area of cross section if the area of the end is small r, area of this wire, the radius of this wire is small r. Josefa, what would be the area of cross section? pi r square. Exactly. Good, Josefa. It would be pi r square. So area will be pi r square. And what is resistance? Resistance is rho L divided by A. So put in the values. R will be equal to rho L divided by pi R square. All right. So note this down and do one more question that I am giving you. All those who will get their answers, just submit your answers on the text. Note this as well as the other question that I'm giving you right now. These 1, 2, 3, 4, 5, 6, these are actually the faces. This is the first face, this is the second, upper face is third, bottom face is 4, front face is 5, and the back face is 6. These are the faces of this cuboid. Hanifa, also write the area of square. If you're saying divided by the area of square, then you have to mention. Let me mention you the sides, then it will be easier for you to write. This will be the breadth of it. Take it as this is the length and this is the height. Now give the answer. Now it will be easier. Akifa, what are you referring to as W?
Width.
Okay, now I've given you the dimensions. Write it in terms of this, Akifa. Rewrite it in terms of this, and I'll be able to understand it. All right, till the time others are referring it to, let's discuss. What about others? I have given you so much of time for this question. Let's discuss it now. See, you have to calculate resistivity of material is given to you as well. You have to calculate the resistance between the points 1 and 2. 1 and 2 means the first phase and the right phase and the left phase. See, R is equal to what? For the first part, R is equal, for every part, R is always equal to rho L divided by A. Means rho will be there. Length is what? Separation between 1 and 2. This is what? The length is what? L. See, this is first phase, this is second phase. Separation between them is what? L. So it is rho L divided by A. Area of cross section becomes what? R between first and second point, it will not be rho B by HL. See, separation between first and second phase is what? This is L. So rho L divided by the area. Area of the square becomes what? B multiplied by the height. Height is H. H by HB. This will be not rho B by HL. Rho B by HL will be for a different one. Now the second part. 3 and 4th. 3 means the upper face, 4th means the bottom face. What is the separation between 3 and 4th face? Faces 3 and 4. What's the separation between them? What's the length? L, B or H?
H.
H. It is H. R is equal to rho H divided by the area will be what? This is the length and this is the breadth. L, B. Third part are between 5 and 6. Rho L by BH, second part is rho H by LB, third part is rho B by LH. Good, Krishna. All the three parts are correct. See, front face is fifth one, back face is sixth. This is, what is the separation between these two faces, fifth face and sixth face? Front face and the back face. What is the separation between them? Look into the figure. Yes, B. They are separated by B. So R becomes rho B divided by the area of this. See, area of this rectangle is what? This is the length, this is the height. Height and length, this becomes LH. So that's how you will answer all the three parts. All right, quickly now note down these three answers of it. Then we'll move on to the new topic. Now see, 4 important topics that we are going to discuss. We'll discuss it simultaneously only. First one is your conductance and other one is your conductivity, these 2 topics. See, conductance is similar to resistance, conductivity is similar to resistivity. How can you relate between conductance and resistance is? It's the inverse of resistance. So conductance is basically, this is the inverse of resistance. Whereas conductivity, it's the inverse of resistivity. So you can easily remember it from the terms resistance, conductance, resistivity and conductivity. It's easier to remember. This is the inverse of resistivity. Resistivity. Conductance is denoted through this capital G. So it will be 1 by R in this manner. This is the formula of conductance. You have a chapter in your chemistry, electrochemistry, I think. There it will be utilized. You have a chapter, I think. So there this is utilized. Conductance, conductivity, the formula of resistance R is equal to rho L by A. There you have it. Conductivity is denoted by sigma. So this will be 1 by rho in this manner. Regarding the SI unit of it, SI unit, what is the SI unit, Hamza, of resistance? Yes, Hamza, what's the SI unit of resistance? Check into your copy. You must have written it under the heading of resistance right now only. It means in today's class. Yes, Hamza. Rishan, what is the SI unit of resistance? Rishan? Resistance, we are dealing continuously resistance. Also, you tell us.
Ohm.
It's
Ohm.
ohm. Yes, Hamza, it's ohm. Rishan, understood now? This unit. This is the symbol of resistance, ohm. Clear, Rishan? So since it's inverse of R, it will be ohm inverse in this manner. This is SI unit of conductance. Now resistivity. Resistivity was ohm meter. So conductivity will become what? Ohm inverse, meter inverse. This will be the SI unit of it. This will be the SI unit of it. So theoretical points also come from this: conductance and conductivity, resistance and resistivity. So these are the basic points of difference. And usually numericals do not come from this portion, but theoretical question you can get, and you can also get the numericals. So 2 topics are done. I told you, 4 topics we'll discuss. The other topic is, that's also easy. These 4 topics, these are easier as compared to resistance and resistivity. Now, another topic that you have is current density. Current density means what? For example, if you have a conductor, the cross-sectional area of this conductor is A. Current I is flowing. So whatever is the current flowing per unit area, you call it as current density. So it is denoted by this capital J. So all of you text me right now, what should be the SI unit of current density? All of you. Each one of you text me, what should be the SI unit of current density? Okay, Akifa and Atif, except for Akifa and Atif. Hanifa, you have area also this time. You have to add something. Area is also there. Kulsum, just I think there's error in your typing or what? Just check your answer. Yes, Krishna. Others, Huzaifa, Rishan Mirza. See, SI unit of current is what? It's ampere. Area is what? Meter square. So it will be ampere per meter square, or you can write it in this manner as well. Ampere meter square inverse. Now, current density is a vector quantity. Current was a scalar quantity, but current density, this is a vector quantity. And the direction is same as that of current. Is same as that of current. This is current density, whatever is the direction of current. If your current is flowing towards the right hand side, then your current density will also be in the right hand side. Similar to whatever is the direction of current, that will be the direction of current density. Now, there is one question that always comes in your exam, microscopic form of Ohm's law. What is the microscopic form of Ohm's law? So, microscopic form of Ohm's law, this is basically an equation connecting current density, connecting conductivity along with the electric field. How? See, J is the current density. This is equal to sigma E. Whenever the question comes microscopic form of Ohm's law, just write this. J is what? J is the current density. J is the current density. Sigma is the conductivity. And E is the electric field. So it's an equation connecting all these three. The last topic means among these four easy topics that we were discussing, it's mobility. Now, mobility is the easiest of all these. Why? Because you already know drift velocity and electric field. You had a whole unit on electric field. You had a whole chapter on electric field. Mobility is basically drift velocity per unit electric field. Per unit electric field. This is denoted through the symbol mu. This is equal to Vd divided by E. So what should be the SI? Just check the SI unit. Drift velocity is a velocity only. So SI units of velocity in every system remains the same. Electric field also, you know. So SI unit should be, write, all of you quickly write what should be the SI unit. Meter coulomb per second per Newton. Meter Newton per second coulomb. Okay, see, Vd drift velocity is what? This is basically a kind of velocity only. So you can write it in terms of meter per second. So this will be meter per second. And electric field, let's write it in terms of volt. Writing what all you have written, that is also right. Coulomb per second, only coulomb per second. Not only coulomb per second. If you're writing in terms of coulomb, then Newton will also come, because electric field's SI unit is Newton per coulomb. Let's write it in terms of volt. Volt is what? This is volt per meter. So this becomes meter square volt inverse, second inverse. Or this can be written as meter square per volt per second. All right, so these are few small 4 topics that you should remember that can come in your theory questions as well as direct formula based questions to come. So note down this as well, and if you have any question, ask me from the whole chapter. Look once into your notes, and if you're having any doubt, just ask me. When you have written it, just text me done. Write it in the chat box done, then I'll get to know that you have written it. Okay, Akifa, Krishna, and Kulsum. Okay, let's wait for others then. So, yes, what about others? Done? Rishan, Atif, Hiba, Huzefa. So most of you are done by now. So see, I'm not starting with another topic or a new topic, but you people have to complete your previous assignment because you people haven't submitted assignments. Most of you have not even submitted a single assignment since April. Only Kulsum, Krishna, Akifa, and I think Atif, they have submitted one or two assignments here and there. The rest of you haven't submitted even a single assignment. So now I'm not starting a new topic because of this, because you people have not submitted your previous assignment. So do it in front of me only, and then make it into a PDF and submit it on WhatsApp right now, all of you. 5 questions are there and you have ample time. Question 5 is just direct theory based question. You don't even need to calculate. So 2 or 3 questions need calculation and 2 are direct theory based. Just quickly write down all the questions with the solution. With the solution, not just a simply answer A, B, C, D. Along with the solution of it, you have the time till the end of this class. Send it in the form of PDF. And make sure you are submitting your assignment from now onwards. Otherwise, I'll start calling you name by name. So in today's assignment, I'll give you very few questions, only 3 questions, not even 5. Though there are hardly 5 questions in every assignment. See what happens. If you are only doing the assignment also, so you will be able to remember whatever has been done in the class. If you're not submitting the assignment, if you're not trying or solving the questions, you won't be able to remember whatever has been done. Because if you're not able to get time for self-study or what, you will at least solve these questions, so that will help you retain. So at least ensure that you are able to do the assignment then and there only and submit it. Right now also, who all will submit it on the WhatsApp, first tally with me whether I have received it or not.
Ma'am, we should send in the WhatsApp or upload in the website.
WhatsApp. That group you must be having, or that number wherever you get the meeting ID, Learnivio number. There you submit it, I'll receive it. But you have the time till the end of your class. So you have around 20 minutes. Last 10 minutes left. Yes, last 5 minutes. Are you all done with it?
Yes, teacher.
Okay, so who all have completed, and quickly make it into a PDF and submit.
So you have to send it through WhatsApp or submit in the website.
No, WhatsApp only. Atif, WhatsApp. but do convert it into a PDF. Josefa, you also.